So since you already know how to solve shear and moment equations and draw shear and moment diagram, so let's proceed now to flexural bending stress and shear stress. Okay? So, proceed na agad ako sa kung paano mag-solve ng flexural bending and shear stress. So, ang kanilang formula is for bending stress, which is FB, denoted by FB, is equal to MC over I, where FB is the bending stress, M is the bending moment. Yung bending moment na to, yung M na kadalasan sinusolve natin sa, yung na-solve natin nung una. Okay? Yung last lesson. Lesson 4. I think this is lesson 5. So, C is the distance from NA to the point where FB is computed. And I is the moment of inertia of section. Moment of inertia, second moment of inertia, dapat dyan is, tawag dyan is second moment, or the area moment of inertia. And then sa shear stress naman, ang formula is VIB times A prime Y prime, or is equal to V times Q over IB. So, what is V? It is the shear force of the section. Pag sinabing shear force, ano yan? Yan yung shear mismo. So, masasolve natin yan. Parang ganun sa ginawa natin nung last. So, B is the width of the beam at the level of shearing stress. A prime is the partial area of the cross-section above or below a line drawn through the point at which the shearing stress is desired. And then Q is equal to AY, A prime, Y prime, is the static moment about the NA of the area A prime. So, i-explain na lang natin yan kapag pagdating sa examples. So, tandaan nyo na lang muna yan. Tandaan nyo muna lahat yan. So, let's proceed. So, example number 19. So, a cantilever beam 69 millimeters wide by 200 millimeters high and 6 meters long carries a load that varies uniformly, varying load, from 1,000 Newton per meter at the free end to 0 to the wall. So, compute the maximum flexural stress. And then determine the magnitude and type of stress fiber 30 millimeters from the top of the beam at section 3.6 meters from the end. So, yan. So, ang i-compute natin dito is maximum flexural stress. Pag sinabing maximum flexural stress, it is also called the maximum bending stress. So, flexural is also bending. Okay? So, sa number 2 naman, determine the magnitude and type of stress fiber. 30 millimeters from the top. So, 200 millimeters high kasi yan. So, ang hinahanapan natin is yung 30 millimeters from the top. So, bababa ka ng 30 millimeters. And that is 3.6 from the end. Yan. So, i-explain natin lalo yan kapag bibigyan na natin ng, ano ba to? Pag binigyan na natin siya ng illustration. So, una is, gawa natin ng illustration ata yung maximum flexural stress. So, ito muna. So, BD is equal to 6 times 200 millimeters. So, yan yung base ND. Depth. Pag sinabing D, that is depth. And B is the width. So, depth is equal to height lang din. Okay? So, L is 6 meters. So, yan yung span length ng ating beam. And then, so, M max. Paano ba i-solve ang M max? Mag-ano ka lang? Mag-moment ka lang sa isang end. So, dapat mag-moment ka na lang dito. Saan? Kahit saan naman. Pero dito, dahil cantilever yan, mag-moment ka sa may support. Okay? That's cantilever beam. Moment ka sa may support. And then, makikita mo dyan is 1,000 times 6 times 1/2 because kinukuha mo ang area nitong triangle na ito. Times 2/3 times 6. Bakit 2/3? Kasi, papansinin mo, kukunin mo yung distance Mula dito sa line na yan hanggang dyan. So, ano ba to? Parang magano kayo. Alalahanin nyo yung tinuro ko ng last. This is 2/3. Diba? Yung malaki is yung 2/3. This one na maliit dito is the 1/3. So, dahil papunta ka sa support natin na cantilever, ang gagamitin mo is 2/3. So, 2/3 times the 6 meters. And then, simplify mo yan. That is 12,000 Newton meter. So, next, I naman tayo. I is equal to BD cube over 12. So, itong I na ito, ibinigay ko na sa inyo yung mga list of formula. Kung paano kunin ang I ng common shapes. Pero, dahil kahit naman na hindi ko na ibigay yun kasi madali lang naman siyang isolve. So, if ever, kadalasan din lang din naman ang kagamitin natin is BD cube over 12. Bakit? Nakakita na ba kayo ng triangle na cantilever? Na beam, rather. Nakakita na ba kayo ng octagon na beam? Nakakita na ba kayo ng ano ba? Circle na beam? No pa? Kaya ba kayong star? Diba wala? So, kadalasan at almost lagi-lagi ang ating beam is always a square rectangle. Quadrilateral lang siya kadalasan. Okay? Kaya ang kadalasan na ginagamit dyan is ito, BD cube over 12. So, I is equal to 40 times 10 raised to 6. So, yung B natin is 60, D natin is 200 pala, sorry, and then over 12. So, simplify mo yan, that is 40 times 10 raised to 6, mm raised to 4. Okay? And then, punta na tayo sa F. B is equal to MC over I. So, mapapansin mo dito, nakuha na natin ang value ng M, 12,000. Nakuha natin ang value of I, which is 40 times 10 raised to 6. At itong C, saan natin makukuha ang C? So, ito yan. So, ang NA natin, ang ating neutral axis is always located at the center of the beam. Kung ano yung center of gravity ng beam natin. So, di ba itong NA na to, diniscuss na to, finding centroids and moment of inertia of common shapes and then composite shapes, yung mga pinagsama-sama. Sinabi ko na to sa inyo. Binigay ko na yung lesson nito na papanoorin nyo. Hanapin nyo na lang sa playlist ng Mechanics of Deformable. At saka, binigay ko na ata talaga to, yung link na to. Okay? So, ang NA naman ng rectangle is always at the center. Hatiin mo lang yung rectangle into 2 sa height niya. Sa height, based on its height. So, dahil 200 millimeters to, hatiin mo lang. So, the NA is located at 100 millimeters from the top, 100 millimeters from the bottom. So, yan. So, ang ilalagay natin dito na C, value ng C is 100. And then, bakit ako nag-multiply ng 1,000? Kasi yung 100 natin is naka-mm at ang 12,000 natin is Newton meter. So, yung meter dito, gawin nating millimeter. Kaya nag-multiply ako ng 1,000. Dahil ang ating I din naman is mm raised to 4. So, simplify. That is 30 MPa. Next. So, determine the magnitude and type of stress fiber. 30 millimeters from the top of the beam at a section 3.6 meters from the end. So, i-drawing natin, i-illustrate natin. Ito yun. So, hinahanapan natin ng magnitude sa 30 millimeters from the top. So, dito. Ganyan. 30 mm. 30 mm. That is 30. 30 mm from the top. And the beam from the top of the section at 3.6 from the end. So, ang tinutukoy niya ditong end is the free end. the free end. So, from here, papunta dito. Dito sa location na to, where it is 3.6 from the end, yan ang hahanapin natin ng magnitude or ng value. Okay? Excuse me. No, sorry nga pala kasi dapat last week pa pala tong lesson nyo. Kaso, nung last week is madalas akong inuubo, kaya ang pangit naman siguro kapag iano ko tong lesson yun ng puro ubo lang yung maririnig nyo, okay? So, ngayon, sorry. So, yan. So, kunin natin yung ano nito, value ng y. Kung paano natin kinukuha yung value ng y. Di ba, mag-ratio and proportion lang tayo. So, that is y over 2.4 is equal to 1,000 over 6. Okay? Makuha mo na yung value ng y, which is 400 Newton per meter. And next, yan. Kunin natin ang M, or ang ating moment at this location. Ano yung moment dito? So, that will be 1/2, dahil 400 yan. So, ulit natin 400. Ayan, 400. So, that is 1/2 times 400, okay, times 3.6 times 1/3 of 3.6. Okay? Kuha nyo ba? Plus 1/2 ulit times 1,000 times 3.6 times 2/3 ng 3.6. Bakit naging ganito? Papapansin nyo, trapezoid kasi siya. Ang hinahanapan natin is this one, ha? Hinahanapan ng moment ito. Hinahanapan natin ng moment. Yan. Okay? Papansin nyo ba? So, ang gagawin ko is, magpa-moment ako sa part na to. Saan ito? 400. Diyan ako magmo-moment kasi dyan yung kailangan eh. So, that will be 1/2 times 400 times 3.6. Ito yun. Hinati ko siya sa dalawang triangles. Yung rectangle, yung ano eh. Kasi sa trapezoid, ganyan yung itsura niya. So, not round to scale. So, hinati ko siya dito. Para magkaroon tayo ng 2 triangles rather. Sorry. So, dyan sa 2 triangles na yan, makakakita kayo ng ganitong triangle. At yung isa is pa ganyan. So, yung unang triangle na kayo nakuha na natin is itong part na to. This one. So, that is 400. So, 1/2 times 400 times 3.6. That is the area of the triangle. Times 1/3 of 3.6. So, dito yan. Ito yung 1/3, diba? Mapapansin nyo, this is 1/3. Kasi yan yung maliit na part niya. So, 1/3 times 3.6. Plus, 1/2 times 1,000 times 3.6. Ito yun. Ito naman yan. Itong part na to. So, this one. So, that is 1,000 times 3.6 times 1/2 area of the triangle times 2/3 times 3.6. So, it doesn't matter kung hindi siya mukhang ano ba tawag? Right triangle. So, the fact that it is a triangle, ganito yung magiging ano niya. 1/2, 2/3 pa rin. So, kung papansin nyo, hatiin nyo yan, this is 2/3 ulit, and this is 1/3. Okay? So, dahil papunta tayo dito sa part na to, that is 2/3 ang gagamitin. So, 1/2 times 1,000 times 3.6 times 2/3 of 3.6. So, simplify, that is 5,184 Newton meter. And then, kailangan nating kunin ang maximum flexural stress at 3.6 or at 30 millimeters from the top of the fiber. So, yan. 30 meters from the top of the fiber. So, ang kukunin natin dyan, dito yung location ng hinahanapan natin ng bending stress. So, ang magiging NA natin, ang magiging value ng C natin is 70. Kasi ang ibig sabihin ng C is, ano bang ibig sabihin ng C dun sa sinabi ko nung una? It is the distance between the neutral axis NA to the point where you are solving bending stress. Okay? So, dito yan. So, ang kanilang distance is 70. So, yun ang gagamitin nyo dito. So, papalitan nyo lang tong C ng 70 at yung M ng 5184. So, yan. FB is equal to MC over I, 5,184 times 70 times 1,000 Newton meter. Yung I natin is hindi naman nagbabago. Wala naman nagbago sa beam natin eh. So, 40 times 10 raised to 6 pa rin yan. Simplify, 9.072 MPa or, ayan, wala nang or. So, that is your final answer. Okay? Ganun lang. So, another example. So, a T-section of a 4-meter simply supported beam carries a uniformly distributed load W, Kn per m, over the entire length. So, the allowable bending stress in tension is 70 MPa and in compression is 30 MPa. So, calculate the moment capacity of the top fiber, determine the moment capacity of the bottom fiber, and find the maximum safe value of W. So, T-section siya. Ito yung tsura. So, yan. Papansin nyo, binigay na lahat ng kailangan. So, if ever hindi binigay, syempre, isosolve nyo yung kung saan yung NA, kung saan yung center of gravity, at solve nyo rin yung value ng I. So, for this example, binigay ko na para hindi na kayo maghabol ng oras sa pagsasolve. Baka hindi nyo pa kasi siya masyadong gamay. So, I is equal to 20 times 10 raised to 6. And then, NA is located 80 millimeters from the top. And it is located 160 millimeters from the bottom. The total length of the beam is 4 meters. So, yan. Ito yung itsura niya. So, this T-section carries a uniformly distributed load na W. Hindi sinabi. And it has a span of 4 meters. So, yan. So, calculate the moment capacity of the top fiber. So, paano yan? MC over I lang yan. So, FP is equal to MTC over I. So, M is wala. So, ang kinukuha natin is moment capacity. Yun yung hinahanap natin. Kasi binigay ng compression and tension, allowable bending stress in tension and compression. So, dito, 30 yung nilagay natin kasi ang compression natin is nasa taas. So, compression is 30. So, that is 30 is equal to MT times 80 over 20 times 10 raised to 6. So, yan. So, sasalpak mo lang naman lahat yan. So, the value of MT is 7.5 kilonewton meter. Ang tatanungin nyo sa akin, bakit naging compression yung top fiber at bending sa baba? So, mapapansin nyo itong part na to. So, this rectangle here na manipis represents this one, biggest one. So, kung papansin nyo, pag nag-bend siya, okay? Siyempre, malalagyan ng load yan. Magbe-bend yan. Tama ba? Pag nag-bend yan, anong mangyayari sa top fiber natin? Sa top. Di ba para siyang nag-shrink? Mag-shrink yan. Sa top. So, that will be compression. Okay? At dito sa baba naman nag-bend siya. Papansin nyo para siyang humaba sa part na to. Hahaba siya talaga. Dahil humaba yan, nahatak. That means that is tension. So, yan. So, yan ang papansin nyo. So, kapag nakasmile siya, nakasmile yung ating beam, that is compression, tension. Kapag nakasimangot, that is tension, compression. Okay? Ganun lang. So, depende lang yan sa loadings. So, kung ang load mo is pababa, that is smiling face. Pag pataas naman, kapag inaangat niya, that is sad face. Okay? Ganun lang. So, next, kaya ganito yung ginamit. Okay? Kaya sa top fiber, ang gagamitin mo is the allowable bending stress for compression. So, at the bottom fiber naman, you will be using 70 MPa for tension. So, FB is equal to MBC over I. So, FB is 70, MB is yung hinahanap, C is yung, ano ba yun? Distance from the bottom to the neutral axis, and then I is given 20 times 10 raised to 6. Yan, 70, yan. So, MT will be 8.75 kilonewton meter. Final answer. So, find the maximum safe value of W. So, para makuha itong W na to, meron tayong formula. Okay? Ay, sorry. Pindot ko na agad. Ay, na. So, may formula yon. So, para makuha yung, yung ating W, yung formula niya is galing sa pagkuha ng moment. Okay? So, meron tayong formula. Kaso, ano lang din siya. Pwede mo siyang gamitan ng shear moment. Sige, gamitan mo ng shear moment to. Okay lang. Shear moment equation. Pero dito, meron tayong shortcut. So, meron na tayong formula for simple span beam. Pag sinabing simple span beam, ganito lang. 2 supports at each end. Yun lang. Itong formula na to is applicable lang sa simple span beam. So, kapag kukuha ka ng safe value naman, ng safe value, sinabing safe value, dapat dyan is yung pinakamaliit. Bakit yung pinakamaliit ang hahanapin mo? Kasi kung kaya nung maliit, kakayanin din nung larger one. Tama ba? Kung ang capacity nung isa is 5 lang, tapos yung isa is 6, ang makakapag-adjust dyan is si 6. Kaya ang kunin mong safe value is 5. Okay? Kasi kapag kinuha mo si 6 na safe value mo, yung may-ari ng 5, hindi niya kakayanin yung 6. Tama ba? Hindi siya pwede mag-adjust. Kasi maliit lang siya eh. Ang mag-adjust dyan yung malaki. Ganun lang lagi. Okay? So, next. So, kaya ang gagamitin nating moment capacity dyan is the smaller one. That will be 7.5. Okay? So, the formula is, yan, WL squared over 8. Yan, tandaan nyo na to. Kasi gamit na gamit to. M max is equal to WL squared over 8. So, M max or M capacity 7.5 is equal to WU yung hinahanap. L is 4 squared over 8. Yan. Hindi ko napalitan. Dapat this one is 7.5. So, W of U. Hala. Hindi ko napalitan nga talaga. So, this is 7.5. So, W of U. Okay. Wala to. W of U is equal to 3.75 kilonewton per meter. Final answer. Yan. So, ganun lang siya kadali. So, next naman, proceed to an example for shearing stress. So, this is the problem. So, as a 2.5 meter simple beam supports a triangular load ranging from 0 at the left support to 10.2 kilonewton per meter at the right support. So, the moment of inertia of the section is 54.17 times 10 raised to 6 mm raised to 4. So, number 1, calculate the maximum shear in the beam. Number 2, determine the shear stress at the NA of the section or the neutral axis. And number 3, find the maximum shear stress. So, for anything else, i-drawing muna natin that. So, ito yung illustration natin. So, kung papansin nyo, it is composed of 3 rectangles na pinagsama. Tapos, nasolve na rin kung saan yung NA nakalagay na. Nasolve na rin yung I. And then, ito yung itsura niya. So, 2.5 meter span beam. that has a triangular load or uniformly varying load. So, same lang yan. Yeah. So, una, ang hinahanap natin is the maximum shear in the beam. So, how do you find the maximum shear? Diba, ang gagawin mo lang dyan is, yan, summation moment ka lang para makuha mo muna yung support reactions. So, yan. So, mag-moment tayo sa A, wherein, kunin natin ang reaction at B. So, that will be 1/2 times 10.2 times 2.5. Itong 1/2 times 10.2 times 2.5. That is the area of this triangle. Times 2/3 times 2.5. Bakit 2/3 ang ginamit? Kasi papunta tayo sa A, sa part ni A. And then, you will be using 2/3 dito. Dahil ito yung nakalagay dyan. Wait lang. So, and then, kung mapapansin nyo, i-multiply natin si 2/3 sa distance na 2.5. And then, minus RB times the distance na 2.5. Simplifying further, RB will be equal to 8.5 kilonewtons. Next. So, papansin nyo, meron na kayong value ni RB, which is 8.5 kilonewtons. Yan yung ating Vmax. Maximum shear na agad siya. So, kahit isolve nyo pa yan ulit, dyan na muna na talaga makikita yung Vmax. So, kahit shear diagram pa kayo, dyan mo talaga makikita ang Vmax. Okay? So, that will be your answer in number 1. So, number 2, determine the shear stress at the NA of the section. So, ayan. So, ito yung formula, hindi ba? So, VFV at NA is equal to VQ over IB. So, sasalpak mo lang yung mga given dyan. Nakikita mo. So, the shear stress at NA will be 8,500. B is 8,500. 8,500, yan to. 8.5 kilonewtons. Ginawa ko lang newtons. Times 150 times 75. Use this portion. Ayan. This is 150 times 75. Okay? Times 75 over 2, which is the center of this portion. Okay? Center niya is 75 over 2. All over 54.17 times 10 raised to 6 na I nyo yan. Times B, which is 150. 50 plus 50 plus 50. Simplify. The answer is 0.44 MPa. And next, so find the maximum shear stress. So, let's talk about maximum shear stress. So, paano nyo malalaman na yun yung maximum shear stress? So, ang pinaka-ano dyan, ang pinaka-tatandaan nyo dyan is, si maximum shear stress, makikita mo siya kung nasaan ang smallest area or smallest B, value of B. Smallest value of B, smallest value of the width. Okay? So, that will be, ayan. So, FB at smallest B is equal to VQ over IB. Wherein, yan, 8,500 yun pa rin ang B. Sa Q natin, that is AY, di ba? Ganun lang din dito. Area nito times the Y prime. So, ganun din yung gagawin natin dito. Pero dito, ang papansinin nyo is, alamin nyo, alin dyan ang may smallest width. So, ang may smallest width tayo dyan is this one. Tama ba? Ito yung magkakaroon natin na yung smallest width natin. Yan. Kasi, kung papansinin nyo, ay, mali yung ano. Okay. Ito. Ito ang may smallest width dyan. Bakit hindi ko kinonsider ito? Itong dalawa. Kasi 50 lang din para sa inyo, di ba? Pero kung kasi, kapag pagsasamahin ko yan, kasi dahil that is symmetrical, those are equal. Magiging 100 ang ano yan. 100 ang kanyang B. So, we will not be considering this one. Okay? That, kunin mo yung area nito. The area of this one is part will be 100. Kasi 200 to eh. This is 200. This is 200 kabuuan. Ang kalahati niyan, yan is 100. And also, this one is 100 din. Okay? So, 100 times 50, kaya ayan. And then, 125 from the top. 125 ang kanyang, kasi ang hinanap natin dito is yung ang ating distance from the center of the smallest area to the NA. Okay? So, that will be 125 minus 50. Okay, 125 minus 50 yan. Over 54.17 times 10 raised to 6 times 50 na value ng B. Okay? So, simplify it further. So, FB at smallest b is equal to 1.18 MPa. That will be your final answer. So, ganun lang siya. Ayan. So, sana naintindihan nyo tong topic na to para makamove on na tayo sa Morse circle. Yun na yung last topic nyo sa akin for mechanics of deformable bodies. So, sana may naintindihan kayo sa mga topics na pinagkagagawa ko sa may in-explain. So, yun lang. Thank you.